Okay, hello. So thanks for coming. It's Friday, it's the end of the day, and I'm standing between you and our final keynote, so I'll try to make sure to stay on point. So again, as already mentioned, my name is Mike Amundsen. I will want to call to attention the drawings that you'll see is from a colleague of mine, Diogo Lucas from Brazil, who has now actually moved to Sydney. I think he's working for Atlassian. So just quickly, this is me. This is how you find me on GitHub and LinkedIn and Twitter. I'd be happy to connect with you and learn what you're working on and what you're doing. If you're into a little Schadenfreude, you can follow this hashtag on Twitter. This is my travel experience, which doesn't always go really well, but it usually is somewhat entertaining. I travel about 35 to 40 weeks a year, so there's lots of opportunity for excitement. I work in a group called API Academy. I'm just going to show this link here. It's a fantastic group of people that travel around the world and listen and learn and then provide feedback. A lot of the book material that I create is with partners from that group. And as we've already mentioned that I've spent a lot of time on books, and I focus on a particular idea, and that is this notion of REST or hypermedia. And in particular, the last one I worked on is for clients, how to write a client that can adapt over time. And writing this book and coming through the challenges of writing this book has led me to the content that I'm going to talk to you about today. And that has to do with the system in general and how we can evolve things. Now, there's lots to talk about. Unfortunately, because of our time, I'm going to have to skip the first one. So I'm not going to be able to talk about living systems, but I will just tell you briefly, what amazes me every day are there are things around us that are growing and changing and adapting, and no one's in charge. No one's in charge in any way. There's no director, there's no architect, right? There's no master architect like in the Matrix, but it happens all the time. This fascinates me. These are complex systems that do all sorts of things. And yet when we create our applications, when we work on things like our own systems, we design systems and build systems and maintain systems, we don't learn from any of these stories. We often build very static statues, sculptures, that sometimes they're great, sometimes they're beautiful, sometimes they're very usable and functional, but they have a difficult time changing or adapting to change, so we do them over and over again. I think some of us like actually doing them over and over again, right? But that's okay. So I'm going to just leave two ideas with you. You'll get these slides later. These are two books that I think are really important if you're interested in looking at this space. Mark Burgess is In Search of Certainty. Mark created CF Engine, if you know anything about systems and system monitoring. And he talks about the challenge of giving up the notion that everything is going to be fixed and certain. And Deborah Gordon writes an amazing series of books on the ants and ant colonies and the ant organism, the group of ants and how they adapt. Ants are the organism that we know of that has no one in charge. No one in charge at all, and yet they adapt and they change and they grow. It's quite amazing. So I'm going to leave those with you. So I'm going to skip on to the next idea, and that is this idea of networks. We heard a little bit of this in the keynote yesterday, but I wanted to focus on it, and I wanted to bring up this gentleman, Pat Hellen. This was when he was working at Microsoft. He then went to AWS, and I think he's now at Salesforce. But I love this quote, "There is no simultaneity at a distance." Why is that important? Because most of us, when we build our applications, we ignore distance of time and space. We imagine everything will happen exactly on time, immediately. YOW had a great talk about all the trouble of what happens when you try to send a message from one place to another, if you get a chance to see your talk. So there is no simultaneity of distance, and that's really important because, as Pat Hellen points out, it turns out our little Newtonian world, the way we normally think of things as cause and effect, which is just a sort of an illusion for us, that's the way we build our machines. That's the way computers work. If, then, else, step, step, step. There's a clock that keeps going. It's inexorable, and we can pick up on that clock, and we can steal some clock time. But it turns out, on the network, that doesn't happen at all. On the outside of the machine, there is no clock. There is no shared clock. There is no shared understanding. There is distance. There is distance both in time and space. There is no simultaneity. In fact, the way Pat talks about this, I think, is really, really illustrative. Think of the speed of light, right? I look up on the star and I see this beautiful star and I say, oh, that's beautiful. I don't really think about the fact that that star may already be dead by the time the light got to me. Think about sending a transaction. Yes, there are 5 in stock. By the time it gets to me, are there really 5 in stock? And yet we always imagine that this distance doesn't exist and that things wouldn't change. So it's really, really important because so many of the things that we learn in computer programming, we're programming a single machine where distance is so tiny. We learn about transactions and locks and all those other things. They all rely on simultaneity. The network does not give us simultaneity. When we think about programming the network, we have to change our way of thinking about it. Because there is no shared now. We even have complex things about caching and cache clocks and all sorts of other things. We actually moved from absolute caching in HTTP to relative caching, right? Keep it for 30 seconds. Relativity, Einstein's relativity exists even in our caching system because of why? Time, space, and time. So thinking about it this way gives us an opportunity to start thinking about how we think of networks. We already saw this story. I think Phil Calcato already gave the slide. I'm not going to review these. These are just another way of saying the same thing that Pat Helen said, is that the network is unreliable because of time and distance. And of course, there's a great talk, I will mention this now, by Rich Hickey. Rich Hickey created Clojure, is the engine behind Datomic, and he has a different way of talking about this. He calls it the language of the system is very different than the language of the machine, and how we can think about doing these things. If you get a chance to see this video, the link is at the bottom. You'll get it in the slides. It's a great opportunity to think some more about how we can start thinking differently. So programming the network is what we do on the web. We don't program a machine. Nobody cares about your machine. Nobody cares about your language. Nobody cares about your data model or your object model. They care about the message. And there's lots of them, right? There's lots of machines. That's what we're programming when we add something to the network. So that leads me to this crazy word, hypermedia. How many people have heard this word before? Okay, how many people program in hypermedia? How many people write HTML? You should have all had your hand up. Right? We don't think of HTML as programming, right? We think of it as something else because we have a different idea of what we think programming is. So just briefly, Ted Nelson, 1965, coins this notion of a hyperlink. 1965, half a century ago. That's amazing. But he's not the only one. Well, I'm having trouble with my clicker here. There we go. 20 years before that, Vannevar Bush, working on the Manhattan Project in the United States to create the atomic bomb, works with all these people, and he understands the way people think. As we may think, we think in connections and links. And he comes up with this notion of this workstation. This looks like a sort of a steampunk version of a workstation that we can use. We load with tapes, and we share information, and we wear a little thing in our hat that actually points to the bit of information to link, and so on and so forth. But even before that, in the 30s, Paul Otway, one of the fathers of library science that we know of in Europe, has this same basic idea. He comes up with a thing called a worldwide network. Oh, so close, so close. So this is 80 years ago, and he has this notion of mixing video and audio and printed material and all sorts of other things. There's such great stuff. If you can spend some time on Paul Otway and what he was thinking, it's quite amazing. He thought that there would be this sort of technocratic city somewhere in Europe, in his Belgium, he hoped, where people would actually go and create all this information for the world to use and have at their fingertips. And this was 80 years ago. So this notion of links and how links make sense and links actually create information has been around for a long time. And yet we don't use this notion at all when we program. And that's a challenge. So hypertext is a simple definition. It's not constrained to be linear. This is one of the things that worries us, right? Because we'd like it to be linear, we'd like it to be serial, we'd like it to be simple, but it turns out that's not really the way the web works. There's another version of it. I have to get a little closer here, I guess. Hypermedia is the term that means more than just text. It's about links and video and audio and stuff like that. But it's not a product. That's another challenge for us, right? I can't go buy it. I actually have to think about it. I have to change what I'm doing. I heard James Lewis just a while ago talking about how it's really difficult to change mindsets. So this is a challenge for us. So it turns out that this notion of hypermedia, this way of creating links, is really the language of the World Wide Web that Tim Berners-Lee and so many other people created. The links are the language. The hypermedia is the language. And that becomes really important to think about. So who's heard this word, affordance? Very cool. We got some affordance people in the room. Affordance was a word made up by James Gibson in the 70s. The affordance of the environment offers what it provides or furnishes, either good or ill. The affordance is what we have here. This is a bottle of water. It affords drinking. Also affords throwing if I want to. There's all sorts of affordances. There's a chair, I can hide behind the chair, I can jump on the chair, stand on it. Affordances are what we can do with the environment around us. And part of living systems is this notion of being able to adapt to the environment and find affordances for food and shelter and so on and so forth. Creating living systems is creating affordances. In fact, Donald Norman, who had worked with James Gibson for a while, Donald Norman is sort of the father of human-computer interaction, has used this term as well. It refers to the perceived or actual properties of the thing. The fundamental properties that determine how it's going to be used. When we create a UI screen, we create affordances, right? Buttons and knobs and so on and so forth. We can do the same thing when we're talking machine to machines. Machines need affordances too, so they know what to do and how to do it. Right? So affordance becomes really important. And in fact, affordance is used by this man. Who's heard of Roy Fielding before? Roy Fielding, infamous, I guess would be the phrase, infamous Roy Fielding for REST and so on and so forth. But here was the exact same thing. What is hypertext to him or hypermedia? It's this opportunity to have affordances. The messages we send back and forth, the interesting part is not the data. Everyone can get data. The interesting part are the affordances, the meta. What's possible? What can I do? And how can I do it? And that's the way machines live in a world. So affordances are the reason we have hypermedia, because links and forms are things to do and descriptions thereof. Describe to me what's possible now. Not describe to me what was possible when you built it last year. Not what was possible 3 years ago when you thought it was going to work, or even 5 years from now, just today, for me. What are the affordances? So what do affordances look like? So we know HTML, right? So the affordance is the A tag, right? The A href, it says you can go somewhere. By the way, this is the very first HTML document that was ever created in 1992 by Tim Berners-Lee, and it still works in the browser today. That's backward compatibility. Atom, if anybody's worked with Atom before, there's some affordances here. It turns out there's an affordance at the entry level. There's a link href, and it turns out there's another affordance just under the title, the link href, which tells us different things. And inside the documentation, this link href as an entry means something different than the one at the top. It tells machines what's possible to do. Call control XML is kind of an interesting way of doing affordances. HAL, hypertext application language, has affordances in these links. There's a language called Siren, which actually even includes field representations and inputs and what's required and what's not. There's a language called collection JSON, which has not just links, but items and links inside items and queries and templates and all sorts of other things. What's unique about these? What's different about these? They're not JSON or XML. They actually have additional structure, we call it highly structured. They tell you what's possible. They tell you where you can find the links, where you can find the forms, how you know which fields to supply, how you know which method to use. And these work in multiple formats, multiple protocols, not just HTTP. So it turns out that these are the types of the World Wide Web. HTML is the type, collection JSON is the type, HAL is the type, Uber is the type, Mason is the type. So if you want to strong type the web in the language of the web, these are the things that you use. XML and JSON are just serialization elements like CSV or plain text. They're interesting, and if I really have lots of agreement ahead of time, I might be able to figure out what I want to do with them. But they're not strongly typed, they're weakly typed. So strong typing are these languages. So that takes us to the notion of messages. Now we have a language, we have a strongly typed language, we can start sending messages. And messages are how we communicate. This is Verplancks' idea of feel, do, and know. I do something, I get a feeling back, and so what's happened in the environment, and now I know what I want to do next, I can interpret it. This is how we all interact with the world. This, by the way, is data, right? It's not really information, but it is data. I can manipulate this and maybe can figure out what I want to do with it, but it's pretty hard. This, however, is information. What's the difference? Spaces and colors. We expect structure to happen, right? We expect to see structure. Structure is just as much information as the data itself, right? That's very important. So messages are how we manipulate the world around us. The Ulm school from the 40s had this notion that of effectors and receptors, and that we would affect the world around us. In many ways, that's what an app is, right? We have a client and we affect some things and it sends some inputs and then we get some outputs and then it displays something. We manipulate these things. By the way, is this information or data? It's information, right? No, it's data. I don't know what to do yet, right? I think I need some more structure. See if we can come up with some structure a little bit later. So Donald Norman, I mentioned Donald Norman earlier. Donald has a much more interesting way to think about the way we manipulate living systems. It has to do with our own way of comparing and interpreting and perceiving changes and performing tasks and specifying what we want to do and planning the next step. It's a constant loop. It's a constant loop. Anybody written a game? It's a constant loop, right? Remember when we write games, we don't tell people what to do. We don't make them linear, do we? We create worlds. And we have loops where we allow people to interact with things. By the way, this might be handy. Maybe this is the schema, the language, the type, the strong information that lets us turn that puzzle into something useful, right? So sometimes that interpretation, that structured information is separated from the data. Sometimes I can apply it. Maybe I could have applied a different structure to the same data to get a different outcome, right? Context is important. So hypermedia is this notion where we have this sort of request, pause, wait experience. That's what a browser is, right? I'm going to request something, then I'm going to go render it, and then I'm going to wait, right? The human does all the extra work, the Planck work, right? Or the stuff that Norman would say. So if we want machines to start interacting on the world, we're going to have to start filling in not just the request and render part. We're going to have to figure out how we can get them to actually make a choice and decide the way that Fielding had talked about. So that leads me to this notion of patterns, and patterns for hypermedia and patterns for the network. So we know a lot about patterns, right? Who's seen this book before? Great book. You should read this book. Christopher Alexander, 1977. He's a physical architect, and he writes this book with the notion is that the same patterns, the same way we have built things, we've done it for centuries. We do it with different materials and different technologies and in different locations, but a door is a door, and a window is a window, and a kitchen is a kitchen, and an alcove is. So he says these are patterns, and he has this program to teach patterns to everyone, not just to the priests of architecture, physical architecture, but to everyone. And that should strike to us as well, right? Can we teach everyone to create systems? So this is a pretty well-known book, Gang of Four. They read Alexander. Within 20 years, they actually write a book about patterns and applying patterns to software. Christopher gets a little upset. He thinks maybe there's been a few things misunderstood, but the idea continues on. We have this notion of creating patterns. Patterns help us interpret things. They add structure. Of course, we listened to Gregor today. I love this book, and the patterns can be very specific to one particular category, like a certain set of problems. I think Phil also showed a copy of this book yesterday as well. This is a great book on the patterns for distributed systems. This is where we get circuit breaker and all sorts of other things. So patterns are handy. Patterns are shorthand to help us think. We can apply patterns to the messages, not just to the code. Because remember, on the network, nobody cares about your code. We care about the message. We care about whether it gets there. We care about whether it has enough context for us to do something. We care about whether we can interpret it. And that's where patterns come in really handy. Okay, so we finally got to the part that I had promised, right? So I want to talk about these patterns in a slightly, in a three-part way. The first set are simply design patterns, ways that we can think about designing the application from the beginning, designing our way of contributing to the network, our way of contributing to the living system. The next set are some principles that we can follow while we're working, while we're actually in the living system, while we're actually being clients or servers. And we don't need a lot of permission to do this. This is just sort of the way we can act, so to speak. But the last four are much more challenging. They're agreements. They're ways where both parties in the conversation need to sort of agree. And we have lots of examples of this in our living world where things have to kind of agree to work out. But they're a bit tougher to pull off. So let's go through each one of those and see how they work. So let's talk about the design patterns first. The first pattern I want to talk about is this pattern that says pass messages, not objects. So typically what we do is we think, as programmers, we want to take those internal objects, those internal object models or data models, and we want everyone else to use that data model or that object model in everything they do. The problem is that's not how it works. You and I, we use the same language, and we may even use the same words, but that doesn't mean we're talking about the same thing, right? The model in my head that I have about how the world works may not be the model that you have in your head. I may live a very different life with very different things, and I may say what sounds like the same. And in fact, the models only exist in our heads. The models don't travel through the air. The models are our internal elements. The messages are something else, and we want to share messages. And Alan Kay talked about this quite a long time ago when he was talking about this idea of object-oriented and so on and so forth. He said he really regretted that. He said the big idea is messaging. It's the message that matters. It's the message going into a place that I don't know, and then stuff's going to come out. It's a contract I have. So one of the simplest way to do this pattern, I may have to switch here, is to just simply, we take all these objects that are internal to us and we turn that into a message that we're going to send to someone. Think about the way we do HTML. We don't send objects in HTML. We craft a message, it follows all the structural rules. I can write an entire accounting system in HTML and never share an object or a database element, right? So this idea of thinking about messages is really important. So bodies should be sent using a highly structured metadata-rich format. I've talked about these formats before a little bit earlier. HAL or Collection JSON or Siren or Uber or Atom or Mason. There's all these formats that are designed specifically for sending messages back and forth without having to share objects. Now, not only are they highly structured, but they're full of metadata, often more metadata than data, because it turns out the metadata is more important. If I say something like, you know what, I saw somebody shoot your dog yesterday. Well, I need some context. Turns out it's a friend of mine with a camera, right? Context matters, right? So it's really, really important. If I say fries or chips or crisps, context matters, right? It depends on where you're from and what you're thinking about. So having metadata is really, really important. So what does this notion of sending messages, not objects, really look like? Maybe here's a simple idea. I need to send some information about orders and inventory. I'm going to get some customer summary, get some outstanding invoices. I'm going to go ahead and get some shipping information, and then I'm going to translate that into an HTML message. The HTML is what I agree to share with the world. That way, if I change things later, change storage and all sorts of other things, the HTML message still lives and still continues. You don't have to know my object model to be useful. We don't have to share the object models or the data models. We just need to share the messages. Now, machines can use their own internal optimizations about models. I can change my model on my app. You can change your model on your app. And we didn't break anybody because we're passing messages back and forth. It changes the contract completely. And there's a corollary to this. And that's using vocabularies instead of data models. Vocabulary is really what we share. Roy Fielding actually alluded to this notion. We standardize on representation and relation rather than objects and object-specific interfaces. It's the actual atoms of conversation. It's the dictionary itself, right? I can arrange those into any sentences I want, into any paragraphs I want with all the proper syntax and commas and so on and so forth, and then we have a chance to talk. I don't need you to get to understand all the paragraphs before we talk. That's kind of useless. So when I focus on vocabulary, that gives us an opportunity to know that even before we started speaking, we know what terms we're talking on. And it really is vocabulary, not objects. So in this example here, I have the same vocabulary operating on both sides, but they're arranged into different buckets or different sentences or different paragraphs or containers, whatever metaphor you want to use for it. And as long as we agree on the vocabulary terms, then I don't need to agree on the exact shape and size of what you send me. And this is really, really important because this means I can also make those kinds of changes without breaking the other parties in the room. So using standardized identifiers for both data and the action elements means that I have a shared vocabulary, and there's lots of good sources. Most of these are standardized at a global level. There are also very particular ones inside each industry. When I'm in the banking industry or the medical industry or insurance industry, they have their own dictionary and set of terms. The really challenging thing about this pattern is that it's non-hierarchical, right? It's not this collection of this is a child of this is a child of this. We don't need to agree on relationships. What we need to agree on are these atoms, these terms, and then we can create the relationships as we're talking to each other. So often when I'm working in a group, we come up with a shared vocabulary, and then we let each team decide how they're going to use that vocabulary to solve their problems. Now, they can't redefine a term. We have some challenges inside mature organizations where they have multiple definitions, just like in a real dictionary, right? There's the archaic version, and then there's the version we have today. But we have to agree on the use of those terms, and when we do that, most of our problem goes away. It's the vocabulary that helps us decide what we want to do. It's not the HTML, it's not the object, it's not the curly braces, it's the vocabulary. Oh, I know what this word means to me. So when we share vocabularies, I can write an application, and I know as long as I'm using the same vocabulary, it will work today, it will work 2 weeks from now, and even new applications that I build will work because we're using the same vocabulary. Now, if I say you can't pass objects around and you have to share the dictionary, suddenly somebody's going to say, well, how do I know what it's actually going to look like when it comes to me? And in fact, there's a great pattern that's been dubbed the presenter pattern by Nick Sutter, who's working on a library for Rails. It's come up in a couple of different versions. In the original design patterns, this is similar to the strategy pattern where I get to actually change my output based on some input information. I think a better descriptor is Hoppy's message translator pattern where I can translate one message into another. But what I'm really doing is translating my internal object message into some external public message. So representing becomes really important. If you ask me for the data from the database, I don't actually saw off a piece of the disk and hand it to you, right? What I do is I represent it as something, right? So what you'll probably say is, can you send me the sales figures as HTML? And I'll say yes. Or you might say, can you send me the sales figures as CSV so I can load it into Excel? And I might say yes. Can you represent the information as a PNG graph? It's the same information. It may not even contain the same bits of data. Right? It's one thing for a big Sparkline app on a large screen, maybe something for a small screen. But this idea of representations, of using these translators becomes really important. I and a couple of people have worked on a pattern called Westel, a web state transition language. It helps us represent resources. There are lots of other ways you can do this. Basically what you're saying is, I've got some machines and they know how to speak different languages, and I can represent the same information in maybe more than one language. I'm a true proxy. I'm multilingual. So a lot of applications that I work on actually have at least one, usually 2 or 3 languages that they can get the information in when they're represented. What does a representer look like from the server side? It might be kind of hard to see this, but it's typically you give me the object graph that you want sent out, and I look at the information that maybe the client has told me. This is an HTTP example. I'd like it in application JSON or HAL or Siren or collection, or maybe I want the Whistle representation. All of these things are ways to generate that information. Now I don't have to have a big argument in my group about which language or which format we're going to use. I just simply have a plugin for that. I just simply add the plugin later, and I'll implement the one today that makes sense, and if somebody decides to change it or they need something or I have a partner that asks for it, I can just create a new representer. Often we need to translate what we're talking about. Let's make that cheap and easy. Let's figure out how to do that. Now machines can even negotiate for the language they want. Look, I understand Siren and HAL. Can you give me one of those, please? It's totally possible to do. We can let machines decide that. And then finally, in this set of design principles, now that I have the possibility of vocabularies and formats, you need to tell me what we're dealing with right now ahead of time. And that's a way to do a thing called profiles. Mark Foster is one of the authors of the profile, of an application level profile semantics, or ALPS specification. And he says it's a way about talking about APIs. It's a sort of a conversation about our conversation. So profile identifiers, there's even an RFC 6906, says this is the profile you can apply to this data. This is the structure, like the instructions to that pile of puzzle pieces. And that gives you a sense of what it's like. So a machine may actually understand lots of profiles, a shopping profile and the shipping profile and the banking profile, but maybe one client just does one thing. I do shipping, I do shopping, I do credit card handling, right? It's like at a movie, you know, you see the movie where it's the trained cat that does all 7 different tricks, right? And like one of those Disney movies, that's not one cat. That's 7 cats, okay? That's 7 cats that look alike, that each do one thing and one thing well. That may sound familiar, right? So Disney's been doing microservices for quite a while. So what happens? We actually can negotiate for the conversation. We say, here's the profile. I'm looking for version 3 of the banking vocabulary. Is that what you support? Yes, here comes the answer. It's in version 3. Or, no, I'm sorry, I don't support version 3. Now my machine knows right away that this conversation's not going to go well, right? So I don't make a mistake because we're suddenly talking about 2 different things. So I have a lot of control over the vocabulary and how I describe it. This is an example of, we won't spend a lot of time on it, this is an ALPS profile. ALPS profiles are very different. They're not like RAML or WSDL or OpenAPI, whatever, Swagger. Those things are definition formats. This is a description format. It says, here are the possible data elements. Here are the possible actions. Some of the actions are safe. Some are idempotent. Some are non-idempotent. That's the story. That's the dictionary. Somebody's going to build an application out of this. Be prepared. But you can't generate any code from something like that. So now I need to know what we're talking about. Now machines can validate that they're talking to the right person, or they're at least talking the same conversation. Think about how this matters now for dynamic discovery. Not only do we need a component that understands users, but I need to make sure they understand version 3 of the user of vocabulary. Okay, all right. So some basic principles. These are things that we can just do right away. Some of these should be pretty familiar. Must ignore. Who's heard of this thing before? Must ignore, must ignore. This is a nice network level or protocol level item. Basically, it's a way to gain extensibility, both forward and backward compatibility. Look, I have a message, it's got A, B, and C in it. I've got a client that only understands A, and B. If I want to run a living network that can survive, that client can't reject that message. I can't know ahead of time of all the things that I must do, right? So instead, I'll ignore C and do my work. We do this all the time. There are lots of ways to do it. We ignore data inputs and outputs we don't understand. Here's an example where I get some data up at the top, and I don't know what that last thing is, so I'm not going to render it. That's fine. But I'm not going to reject the message just because somebody slipped a little Italian in on me, right? Just like we do in conversation. Somebody says some word I don't understand. I don't say, we're not talking. I just let that go by, and we keep talking. Maybe I can learn too, who knows? So ignoring what we don't understand lets us do our own thing without us having to know what everybody else is doing, right? I don't have to know your job. I just need to focus on mine. As a matter of fact, this will increase our ability to collaborate, increase our ability to connect things together safely. So it's really, really important that I not always be the one that knows everybody's business. Nobody likes that person anyway. And there's a corollary to must ignore, and that is must forward. So this is actually an element in protocol as well. We do this all the time in HTTP and caches and headers and things like that. Forward the things you don't understand. Don't strip them out, because the person you're about to hand them to, she probably understands what that means. So don't become the bottleneck for everything else. So this is very similar. So I get a document that says A, B, C, D. I'm only interested in manipulating A and B. I'll pass on my manipulated A and B and C and D to the next party. Right? That's the way real life works. Now, there's a bunch of things. No, I ignore those. Just sign at the bottom. Okay. We do this all the time in real life. Right? So forward unchanged any URL or forms that you don't deal with. So here's a kind of similar example to what we were talking about before. So I'm getting a message on the top, and I understand a couple of things. I manipulate those things, and then I just send the rest of the message on, no problem. Now, this is usually where people get a little nervous. They're worried about they're getting tricked into lying or doing or smuggling or stuff like that. Well, you can have enough intelligence to make sure you don't do something bad to somebody else. But you also need to pay attention that you're not affected as well. So it means we're defending things a little bit differently. We don't edit for others around us. We let other people say, participate in the conversation. And that's what we want to do as well. We can now cooperate without having full understanding of everybody. Here's one that I find really, really handy when I'm building applications. We know what this is, right? Most recently used, MRUs, right? This turns out to be incredibly important for machine applications, for machine-to-machine conversation. So this is the best definition I could come up with. I don't know who really came up with this idea. Probably somebody at Xerox PARC originally, something like that, or somebody. Maybe somebody can help me fix that. But you know, if I keep doing the same thing over and over again, maybe I can cut down on the conversation and have the person talking to me start to just send me this information all the time. You know, you're doing a lot of ads and searches, so I'm just going to include that in all the responses from now on. You know, part of the thing in Hypermedia is this notion that I'm supposed to start with one link and follow to the thing that I need. Well, if I have to follow 17 places, if I have to run a race before I finally get to the cheese, I'm going to go find another place to buy cheese, right? Make it easy for me. So if I'm using things a lot, modify that. This especially works in a stateful or identity context kind of situation. So we can return the links and forms that are often used. And that means we have the same situation here where it turns out I make a request for search, and when I get the answer back, that search link is going to be in that document again because you know you might need it again. And then maybe if I do an ad, maybe the search and the ad are going to appear in the response because I might need it again. And we can do all sorts of things just like we do in real human interfaces. We can decide how many we want to offer and so on and so forth. This now makes it possible for me to actually have a conversation with you without giving you the entire answer, right? I can just give you sort of a short answer, and if you're interested, you know, you can ask. Or if we need to, we can improve the quality of our conversation. So now we have the most needed tools at hand, and eventually we can even use machine learning to start even predicting, you know, most of the people who do searches also do this, so I'm going to send you this form. Right? We can use all that material now at our disposal and make it easier. And here's another one, idempotency. Who knows this word? Very cool. Idempotency is this notion that I can repeat the same action again and get the same general expected result, right? So the way we do reads and writes in HTTP, for example, we actually do them using put and post, right? So put is the one that's idempotent. I can repeat put. If I just put the same value into the server, the same value is going to get stored. Post is different. If I do a post, it's going to create a new record or something like that, right? So they decided in HTML they would only support one of those, right? Right? The one that is not idempotent, the one that can't be safely repeated. That's a kind of a bummer, but that's kind of the way it works. Idempotency is really handy because we can keep repeating, and machines are dumb, so machines can now safely repeat. So if I don't get a response, YOW had a great explanation of this from the caching perspective, but if I don't get a response the first time, I'll just do it again. I'll do it again, and there'll be throttles and things, and eventually the person I keep doing it again to will either tell me to go away or I'll go away. But now I can safely do this without ending up charging somebody's account twice, or 2 times, or 3 times, or getting confused in the process. So one of the things that I work in my applications is to always use idempotent updates, always use idempotent mutations. That way, it's really difficult to screw that up, even when the machine might act in an unexpected way. So here's a pretty good example that actually not only uses idempotency, but it uses a little bit of retry as well. Look, it didn't work, I'll go back and do it again. So I can do it a couple of times before I give up or I'm told to go away. And I know that that's not going to result in something untoward, at least not as long as we all agree with everything else. So if things didn't work, I can try again. So now try again is safe for an unsupervised machine. And that leads to the last elements, these shared agreements. It's a little bit tougher. Both parties have to kind of agree to this kind of stuff. So the first one is very similar to MRU. I call it use related. And actually, I pull this from an idea from Google. Google learns what you're doing and then says, you know what, here are all the other things that you could possibly do if you like. And that's good UI design. So there's lots of things going on here. There's lots of possibilities, A, B, C, D, E, F, G. If I have to send this message every time, that's going to be really onerous and complicated. It's a lot better if I send you the common elements and then one more thing that says, by the way, there's some other stuff you might be interested in. So I know I can tell a machine, look, go find the link that finds all the outstanding orders. And he looks at the page and says, you know what, there's no link for outstanding orders here. Ah, there's a related link. Let me click on that, and now I get the menu set, right? Ah, there's the link for orders. Thank you very much. I move on. I go use that link, and what's going to happen? I'll get it as an MRU the next time anyway. So next time I won't have to go so far, right? So this notion of use related is really, really powerful. It's a thing that both parties have to agree with for it to pay off though, right? The servers have to provide it and the client needs to look for it. So here's a great example, right? So I want to approve some invoices, but actually it turns out I wanted to modify one in some kind of way. I can follow related and get all sorts of things. And sure enough, there's the modify one I need. So that's a really handy agreement. I can't remember everything. You don't need to tell me the whole story every single time. Now I can actually have a pattern for looking things up. And that's similar to the navigation one. This is a tough one. So navigation is being able to break this into smaller tasks, right? And machines are great at this. Machines are great at doing tedious things over and over and over again. Humans get a little annoyed. Just tell me everything now. Don't just keep dribbling it out to me. But machines, at least so far, they don't get annoyed. So I can create this navigation agreement, and that navigation agreement needs to have more than next and previous. I may want to restart it. I may want to just give up and exit. I may need to know when you think I'm done, right? So by creating this set of vocabulary terms and providing these links and forms, I can actually create a way for a machine to get through a series of steps and then change the number of steps, right? I need you to supply a whole bunch of information in 3 steps. You know what? We're going to change it to 7 steps. That machine's still going to work because that machine's going to understand how it needs to interact. I'm going to next, I'm going to next, I'm going to next, until finally I'm either done or I don't feel good about this conversation. You're asking for stuff I don't want to supply. I'm going to exit out, or I think I want to restart. We can provide all this power to the machine as well. So having this set of next, previous, cancel, restart, and done works really well. And you can write a client that actually understands the story. Look, I'm looking for a certain thing here. Is it here? And if not, I get down to the bottom. There's a thing at the bottom that just says cancel, right? Or exit, or just stop. So now I can build things that can expand and grow over time if they need to. Because I can't keep all the steps in my head. And in fact, this is a fundamental problem with writing applications, is we try to memorize all the steps every single time. And that means that if the steps change, everybody's wrong. Now I got to go update everybody's app just because I added one more step in. Whereas if I can start to make that flexible and have machines help us out, it'd be a lot better. I love this one, partial submit. I use this both for humans and for machines, as a matter of fact, and it comes from our friend Donald Norman. Donald has this great line, think of actions as approximations of what's desired. You know what? This is what I want to do, but I didn't fill it out quite right. Can you help me out? Did I get close? Right? So if we have these long, complicated forms and I get one of the fields wrong, if you reject the whole thing, I'm pretty pissed, right? It's like, I got to type all this again? I got to look for the red thing? I don't know. So the pattern that I like to use is this notion of partial submit. The server wants A, B, and C. If I submit A and B, it'll say, fine, okay, I just need C now, and we'll be good, right? I don't say no, try again. I take a step at a time. And again, machines are fantastic at doing this. Really, really good at this. So this accepting partially filled in forms and then adjusting the state is really, really handy. And what does that look like? Here's a pretty good example. Somebody supplied some inputs. I process the form. If I get some needed inputs back. If that's 0, we're good. If it's non-zero, I'll create a new form, decide some buttons that are going to show up on that, and then wait for the response again. Now, eventually, I might find that I keep asking you for the same thing, and you're not getting it, right? Did I do something? I ask you the wrong way. I'm using something outside the vocabulary. So as a server defender, I'll treat that almost as a DOS attack, right? I'll say, well, OK, we're done. Thanks anyway. Don't need anything more, right? So we have that power as well. Sometimes I only know part of the story, or I can only get part of the story out at any one time. Maybe I need to go somewhere else. Maybe I need to come back later. Sometimes this is called a work in process pattern, too, by the way. Last one I want to talk about is the state watch pattern. This is a pretty difficult one, and I'm going to be honest with you. This is a bit of a stretch goal. I have not got a good working version of this yet. I've been toying with this in a couple of different ways. I get this idea from Jens Rasmussen. I don't know, does anybody know Jens Rasmussen? He designs interactions and interfaces and learning systems, and he has this wonderful theory that I'm just going to touch on briefly, and that is a signal, sign, and symbol. The signal is the actual bit of data you get, like the temperature's getting a little bit high in the refrigerator. The sign is actually an ability to determine what that actually means. Like, this is a sign that maybe the door is open, or this is a sign that the heat regulator is broken. And the symbol is what it tells you to do. Oh, this symbolizes that I need to check the door and check the heat regulator, right? So we can design machines, and there are lots of machines that operate like this today, manufacturing machines that operate on this notion of signal, sign, and symbol. And it also can become a handy way to start learning as well, as you sort of separate the notion between the signal and the noise, the actual signifier, what's really going on, and then what it symbolizes I could be thinking about doing. So in StateWatch pattern, I use this notion of how signals are really important, and I come up with this idea that clients should be able to decide when done is done, right? Clients are in charge of their own life. So clients should be able to say, listen, I'm going to be manipulating a few things. You need to tell me the value of state X on every reply. Until it gets to the value I want, I'll probably keep manipulating. And then I'll tell you when I'm done. Right? So if I'm, again, regulating temper systems or maybe, you know, buying and selling and stuff like that, that becomes really important. So I set the standard. Services should be able to supply watch values, even give you a list and say, look, these are the things you can monitor and look at. And then you can pick the ones that are interesting to you. So here's a particular pattern. I actually borrowed a prefer header. I'm doing these in HTTP today. So I borrowed a thing called a prefer header. The prefer header lets me sort of communicate some out-of-band information outside the body. And I says, look, I want to watch sensor 5 and temperature 13. And then the next time around, it turns out that I'm increasing the temperature on sensor 5, and I want to get that information back. I want to get some information on the value of the temperature, and so on and so forth. So I can decide when it's over. My job as a client isn't just to do whatever the server tells me, it's to actually solve a problem that the server may not even know anything about. So I can set my own thing accordingly. Okay, there's a lot there. Let's just kind of summarize a few things. And then we can talk a lot after, in the break later and also in the social. So programming the network is a new set of challenges. It's not like programming a machine. We have to start thinking about time and distance. We have to start thinking about what we control and don't control anymore. Hypermedia is the way the web works. It's the way we can do nonlinear things and point from here to there and everywhere. I can add anything, anytime, anywhere without asking permission from anyone. And that's a powerful element. And the way we talk, the strong typing of the web is these hypermedia types, these highly structured formats. And they're specialized. Some formats are very good for one thing and some for another. But learning that strong typing, going beyond that weak type notion of JSON and XML is really important. We live in a world where we manipulate and we wait for response and we decide and we manipulate again. That's how we write every game. That's how you drive to work. That's how you get on the bus. That's everything we do. We need to start building our client and application systems like that and apply patterns to messages, not to code. Code is fine, but it's the messages that are important. So I'm just going to skip through these. You've seen these before. There's lots of these design patterns, principles, and agreements. I think this is a pretty tight set. It might be a little repetitive. There might be some things missing. I'd love the feedback. I've actually created a GitHub repo that has a sort of a simple set of these, a simple example of these. Pull requests, comments, issues, all sorts of things would be quite handy. And again, you'll get these slides a little bit later. And I just want to end you with this quote that I really love from Paul Clements, who worked at Carnegie Mellon. The best software architecture knows what changes often and makes that easy. What changes often in your world? How can we design systems where change is easy? And I think that's the challenge. Hopefully I've kind of given you some ideas on how you could pull that off. And I just want to say thank you very much. Thank you. Thank you. You good?